Hey guys, welcome back. This is Frank, and welcome to our IGCSE COSI chemistry revision videos. Our current unit is C5 Detective Chemistry. So today I'd like to talk a little bit about identifying anions. This is one of the, I guess, most difficult and tedious part of the unit. There are a lot to memorize, and I guess, um, you know, as long as you understand, it will be quite easy for you to recall what to do. But if you don't understand, then it's harder for you to memorize. So I will try to explain as much as detailed as possible, but it's really at the end of the day up to you how you would memorize it. So yeah. Anyway, so let's start with taking a look at the list of stuff we're gonna identify today. So we have carbonate, chloride, bromide, sulphate, nitrate, and ammonium. And as you might have seen, I have grouped them together. Carbonate, chloride, bromide, sulphate together, and nitrate and ammonium together. This is because groups these four have like similar tests, and these two has similar have the similar tests. So yeah, we're gonna start by looking at carbonate, chloride, bromide, and sulfate. So to begin with, for all of these four, important part is that before you do anything, you must acidify the solution. All right, so acidify, and acidify unsurprisingly means add acid. So you would add acid, and you will see why in a second. Because if you add acid at this stage and you have carbonate inside, I have used purple to represent carbonate. And for your information, these color codes are only for reference. So like you know which one's which, but it's not the actual color of the solution or whatever. So don't get confused. I'm just using it here to so that you can know which one's the reaction for which. So if you acidify, if there is carbonate ions present, you would observe what we call effervescence. So I could never spell that word, but yeah, something like that. Effervescence, and basically this means bubbling. All right, so you would see gas produced, and in order to test for what gas it is, you run it through run through lime water, and unsurprisingly, from our identifying gases part over here, you would see that um, we use lime water for the carbon dioxide. So it would turn the lime water milky. So I will mention here, oh, I don't know what happened to my R, but lime what? Lime weight? Lime water, and turns turn lime water milky. Uh, and this indicates that CO2 is produced. Write it this way. CO2 is produced, and carbonate ion is present. Is present. All right. So I mean, if you think about it, it kind of makes sense because it becomes carbon dioxide. It displaces the hydrogen in the acid actually displaces the oxygen in carbonate ion to make it carbon dioxide, and then you have the hydrogen from the hydrogen ion from the acid, and then you have CO3. You have the O from CO3. So yeah. Anyway, moving on. If it is not carbonate, however, for chloride, bromide, and sulfate, unfortunately, nothing would happen at this stage. But just to acidify it so that you can get rid of carbonate. And then next up for chloride and bromide, I would actually write this in. Uh, you know what? You know what? I can do this. Oh, okay, I'll come back to it later. Okay, so we have chloride and bromide, which is this pink color. They would need to um, add silver nitrate, if I recall correctly. So add silver nitrate solution, CO2 is produced. Add silver nitrate solution, or I would say it's AgNO3. Yes. So AgNO3, AgNO3 solution. We'll put this over here. So add AgNO3 solution, and yeah. So going back to the acidify point. For carbonate, it doesn't really matter which acid you use because it will always give off a hydrogen ion. But for testing for bromide and sulfate, chloride. Sorry, you have to beware that if you use a different solution, it might give a false positive. All right. So if you uh, if you use, you wouldn't use hydrochloric acid to acidify it if you're testing for chloride anyway, because even if you added AgNO3, you added silver nitrate, and then uh, it's gonna precipitate with chloride ions. So what's the point of adding hydrochloric acid? Because if you add the acid and you add the silver nitrate, of course it's gonna precipitate. So you won't. It won't tell you if the original solution that you wanted to test for contains chloride or bromide. So in this case, the safest move is to acidify with nitric acid, so HNO3. So instead of using HCl or I don't know, other type of different acids, you would rather use nitric acid, so that when silver nitrate goes in, it's guaranteed that it will not make a false positive precipitate. So yeah, that's chloride and bromide. And if the test is positive, you would find. I will underline this in pink so that you know it's also applicable for chloride. Bromide. And if it's chloride, then you would expect to find a white PPT. All right, and if it's bromide, you would expect to find a cream PPT. Now, the actual difference between these colors is very subtle. So cream is more like a very very light yellow, but not quite. It's like somewhere between white and yellow, like a really 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 light yellow. So yeah, but in scientific words, you would say cream precipitate, and uh, yeah, and this is because when we have Ag plus aqueous and Cl minus aqueous, it will give you AgCl, which is a solid. And similarly, Ag plus aqueous with bromide ions minus aqueous would give you AgBr, which is also a solid. So this one's white and this one's cream, and that's why it has different color precipitate. All right, moving on. We have sulfate, and for sulfate, the test is actually different from using chloride and bromide. So I would label the test like this so that it's easier. Sorry for the confusion. This is basically what happens. Okay, so if you acidify and it has effervescence, so like if it bubbles, then there is carbonate present. If it doesn't bubble, then you have to test for chloride, bromide, or sulfate, and sulfate actually. So yeah, let me change to the sulfate color, and in order to test for sulfate, you would add HCl solution, I believe. So add BBR no BaCl solution, so barium chloride solution. Uh, Barium chloride solution. You would acidify this with HCl actually. So similar to above, where you acidify with HNO3 for HNO3 solution, you would acidify with HCl for BaCl solution. This is to prevent false positive. Okay, so when you add BaCl solution, you would probably get hopefully a white PPT if it's positive. So white PPT. And this is because, let me move all of these up. Actually, I'll shrink this so that it fits. I'll shrink this so that it fits. And we're going to continue writing over here. And this is because barium ions in the barium chloride solution would combine with sulfate ions and give you barium sulfate, which is solid and it's white. So that's why you have a white precipitate, because you have barium sulfate. So I will put this down here, and that's all we have to know for these. I'll move it over here, and yeah, cool. So moving on, we have our nitrate and ammonium. I would put this down here. All right, so these two guys are completely different. So they have a completely different test. So first of all, they have many steps in common. All right, so common steps I will write in red. Common steps is that you would warm it first of all, so that the rate of reaction will increase, and then you would actually have well, it depends if it's nitrate, and only if it's nitrate you would add aluminium powder. Now this is because if you have nitrate and aluminum, you would have and it would oxidize the aluminum, and it will combine with the aluminum, and it will actually be more likely to get hydrogen ions from the sodium hydroxide solution we're gonna add later. So it will become ammonia. So that's why you will have to add the aluminum powder. But I'll explain the rest of the steps first. So you will add aluminum powder only if it's nitrate, and you would add sodium hydroxide solution, and yeah, as you've warmed it, it would react quite fast, and you would test gas evolve with red litmus paper. And as you might have guessed, if we look back to our identifying gases part, red litmus paper is used to test for ammonia. So it will turn moist red litmus paper blue. So that's why in here, test gas evolved with red litmus paper. It will turn red litmus paper blue. All right. So this is because this is because if you have NH, I will use ammonium as an example. So if you have NH4 plus aqueous, and you have hydroxide minus aqueous, you would get water and ammonia. So that's why you have to heat it or warm it so that it would actually work. All right, so I'll put this over here, and yeah, okay. So that's all we have to talk about today. And actually, you know what? It might be a good idea. It might be a good idea to put these down there, but okay, I'll change that later. So anyway, today we learned about identifying anions, and especially carbonate, chloride, bromide, sulphate, nitrate, and ammonium. And yeah, for these four, we learned that we have to acidify and see if there's bubbling, and add different type of solution and have different types of results, and that, my friends, you would have to memorize, unfortunately. Hopefully you would get it, if you remember your knapsack rules really, uh, really clearly. You will try to use some different examples. Try say, instead of, let's say, instead of using barium chloride, why don't we use barium, I don't know, barium nitrate or whatever. I try to think of these and look up the NACSEC table and realize why these tests are the best. And yeah, after you learn that, it will be much easier for you to memorize. And yeah, it's all back to the solubility rules, really. So learn your NACSECs, or whatever your version of the solubility table is. Learn that. And also for these, I guess the most important thing is that, just learn that hydroxide with these guys would give you ammonia. And I mean, if you think about it, that's kind of obvious because nitrate has nitrogen in there, and ammonium is just ammonia ion, sort of. So yeah, it will make sense that it will involve ammonia, so that you can think backwards and say, oh, hey, that's gonna test with right litmus paper or whatever. So yeah. Hey guys. So I was just looking over my notes and I realized I forgot to talk about why carbonate makes carbon dioxide. So the reason behind it is that when you have let me change it to carbonate color. When you have CO2, I mean CO3, sorry, CO3 carbon ions, and uh you have two H plus ions, hydrogen ions, you would get let me move this away for a bit so we have space to write. Move this here over here. It would give you H2O liquid plus CO2 gas. All right, so it will give you water and carbon dioxide. So that's why when you add acid in carbonate, it would the proton. Their acids are proton donors, right? So they would donate protons or so-called hydrogen ions, and it will turn the it will combine with the oxygen from carbonate ion, and carbonate ion will be left with carbon dioxide. So hopefully that helps with memorizing things a bit. Hey guys, I've just realized again that I did talk about ammonium, but I named this episode identifying anions, which is incorrect because ammonium is not an anion, but it is a non-metal ion. So and it has a similar test with nitrate, so I did group them together. That was my bad, sorry. But yeah, I hope you get this. And I've also cleared up the notes a bit, so you can have a look here. And yeah, I think that's all I would have to talk about today. So hope you learned something here, and I will see you guys in the next video. Bye.